So if you've been following along at home, it probably hasn't really felt very much like programming, but today I promise it will. Hi there, I'm Roy, and welcome to My Code Corner, where I take a hands-on approach to learning topics of computer science. And today's topic, very important one, very programmery, that's not really a real word, but we're going to talk about conditional flow controls. And I promise you, if you stick around to the end of this video, I've got a surprise to help you advance in your programming career. But definitely make sure you hit that subscribe button and join the community. But let's go ahead and jump into our compiler and get coding. Before we start talking about flow controls, I wanted to actually talk about a couple little bonus sections, things that we're going to start using a lot more as we get into coding and will help with our surprise at the end of the video. But the first one, imagine if you want to logically group some code together. Well, in C and C++, there is a way. There is a way we can actually group that code together, and it's known as a code block. So I'm going to go ahead and show you what that is. Well, code blocks are actually extremely simple. To create a code block, all we use is an open and curly brace. Actually, everything inside this is logically grouped together. Now, I can put anything I want here, and in this case, other than readability and knowing that whatever's in this block is together, it's not really doing anything, at least nothing that you see right now. This is the way you actually create that code block. So a lot of times when you hear people says, grab a block of code, this is usually what it means. This is logically grouped together. And so if I hit play, of course, those curly braces in this case are not doing anything special, but as you see, it just says encode block. It didn't deviate, it just ran as usual. The second thing I wanted to talk about is what's called pseudocode. A lot of people call pseudocode code without the semicolons. Imagine if I wanted to specify what this line was going to do. This is honestly where you can write things. I do this a lot before I want to code it. I want to get my thoughts out. So I'll write some pseudocode kind of saying what it's going to do without that syntax. For this, inside this code block, I want to print in code block. I could honestly say something like print in code block, and that's it. Do I have to put it in parentheses? No. I really can put anything I want to, but what pseudocode is for, again, it is so you can actually start documenting what your algorithm is doing, what your code's doing. It may be for future people looking at it, especially if you have very complex code. Or again, it may be just for you that if I'm building something and I know there's going to be a lot of code and I want to just get my thought pattern on the page without worrying about syntax, you would rather get those ideas on virtual paper just so that you know what you're doing and don't forget. Of course, pseudocode was always going to be commented because, again, if you look here, this line here will not compile. Reason I'm mentioning pseudocode now is that since we are now moving into a little bit more of the logical flow of programs, what I'm going to do is before I actually write the syntax that we're going to use, I'm going to actually put down pseudocode so you kind of know what I'm doing. With that being said, let's go ahead and get to conditional flow control. Now, what exactly does that mean? If you think about it, think about a river and you might have a set of locks and dams. And you might, on Monday, Wednesday, Fridays, you want all the water to go through the left side, and all the other days of the week, you want water to go through the right side. You need something that would actually direct that flow. And when you're actually working in programming, but there is a flow. And right now, as we've written quite a few lines of code, a few hundred lines already, you've noticed that it kind of goes from the top to the bottom. And it's just one line after another, after another, after another. Well, there's times that you're going to need conditions of whether or not your program is going to flow one way or the other. Is the water going to go to the left or the right? That is, in essence, what flow control is. You're controlling the flow of your program going from the top to the bottom, and it's going to be controlled with a condition. Most of the times, those conditions are the Booleans, which is why previous session, I really, really, really wanted to hit Booleans, because it's vital for this. Understand that not every flow control is Boolean controlled. There is other ones, and we will get into it in this episode, but most of them are going to be Booleans. So the first flow control, the easiest one we're going to talk about, is a statement that's known as an if statement. Simply, the way this reads is if a condition or a Boolean is true, do something. Otherwise, you don't. You're only looking for that positive value, if true. So if I write, I'm going to go ahead and do my pseudocode. I'm going to say if x plus 20 is greater than 100, and of course this right here is a Boolean operation. If it is greater than 100, I'm just going to print x equals x. Simple pseudocode. But what does this mean? As I mentioned, that first command we're going to use is an if. And so this command does start with an if. And after that if, you will have that Boolean conditional. Now that Boolean conditional does go in between parentheses. So really, this is a case of the Boolean operation that we're going to do has to live within here. I could say something as easy as if true, because this is a Boolean. I could do that print that I just wrote above. And of course, this one is not going to compile because I still need to declare myself an X. Matter of fact, I'm going to go to the top here and I'm going to declare a couple variables. Let's see, we'll see an int X equals 90 and Y equals 14. A couple variables that we have to play with, and we'll use these a lot in our code today. But in this case, I am looking at this if statement. If the value in here is true, which obviously is going to be true because we're specifying it right here, it will print this out. And if I hit run, of course it still says in code block because this doesn't change, but we know because we set the variable equal to 90, x equals 90. So of course we print that, and then we printed this because we know this true is true. Kind of says it in the name. But obviously that's not what our pseudocode said. Our pseudocode actually did call out this equation of x plus 20 is greater than or equal to 100. Now, just doing a quick desk check, just looking at the variable, I know that x is 90 plus 20 is definitely going to be greater than 100. I'm going to go ahead and write this out. X plus 20 greater or equal to 100. Again, in our head, we knew 90 plus 20 is greater than 100, so this should print this. Will tell me what that x is, and of course that x will still be 90, and I'll explain why here in a second. And it is. And the reason why, if you notice, the x started at 90, we did this equation, but it did not change x. And the reason being is x was never reassigned. All we did was use the variable to perform this left half of this Boolean equation. So all we're trying to say is that 90 plus 20, is that greater than or equal to 100? If it is, print this. Now, what about if this was false? Of course, I can make it false in multiple ways. I could actually set this x lower, or I could set the second half. So in this case, 90 plus 20 is still going to be 110. Is 110 greater than or equal to 1,000? Well, it's not. So what will end up happening when I hit run? It doesn't go into it. And the reason being, our Boolean here basically returned a false. So in this case, if it's true, it will print, in this case, the next line. If it's false, it will totally skip over it. Now, I did mention code blocks before, and this is where code blocks become very, very vital. Because whenever I have these if statements, even though I do have this line, and let's say I did line 2. In this case, I do have a second line here, and I'm indented once again. But if you remember before, indentation does not matter in C and C++. If you're programming in languages like Python, 100%, and we'll go with that when we start talking Python. But in this case, this line 2, even though I've indented it, it's not, well, let's go ahead and hit run and see what happens. And so you see in code block, you see it skipped over that x equals because our Boolean condition was false, but it then printed the next line. Now, what if I wanted to basically only print both of these lines if this equation is true, and if it's false, skip them both? That's the reason I wanted to talk about code blocks. Because what happens to this if? It's not the point of it will only perform the next line. It will perform the next block of code. Again, a logical block. So if I really wanted to do both lines, only if this equation is true, I would have to surround this with a code block. And so in this case, whenever I hit run, you should only see that in code block. You won't see the other two lines. And if I go back here and remove that 0, so I make this once again true, hit run, and it will print both lines. Again, what happens at the end, that logical grouping of code, that's what's actually being performed. So that's it when it comes to an if statement. Pretty straightforward. Basically, if whatever's in here is true, do what's in the code block. Otherwise, move along. Now, sometimes you want something different, because what's going to happen in this case, as I mentioned, I'm going to say outside if. And in this case, if this is true, it will print this and then print this. If this is false, it will not print this, but it does print this. Well, what if there is a case where if it's true, you want to do one thing, or if it's false, you want to do something else? You don't want to, it's one or the other. It's that case of, does the water go to the left or go to the right? In this case, if this was true, water goes to the left. After that, all the water goes to the right. There is no way we can say we're not going to do this. Well, there is a statement, and that is known as the if-else statement. And it is exactly as it sounds. Basically, if it's true, do block 1, else do block 2. And we'll go ahead and show you with some pseudocode what I'm talking about. So in this case, let's say if the equation 3 times y is not equal to 42, we're going to go ahead and print value equals y times 3. Otherwise, print the value is 42. But that makes sense, because if it's not equal to 42, print what it really is. Otherwise, it will be 42, because that's going to be the equal, because that would be the false case of this statement. So going back to what we had before, we have this if statement. And of course, the if statement will be exactly the same. If we have a Boolean condition, 3 times y is not equal 42. And I will say sometimes when you're writing some of this pseudocode, you may actually just take this right here, copy it here. Of course, it's not going to work, but I can take this not equal to, go bang equal, and turn this into that equation I'm trying to do. Great way, like I said, if you're running quickly, you can do this. You'll see me, especially with things like these prints, I will use this a lot. But it's just, since your pseudocode is really just a kind of a shorthand code, you can rapidly do this, especially when you're trying to do things quick, which you will see me do soon. But you can convert that pseudocode relatively quick. But we have this 3 times y does not equal 42. Of course, I'm going to go ahead and do, like I mentioned before, I'm going to create that code block just so I have my grouping of code. I'm going to print, first of all, am I going to print? Go ahead and print everything here. Value equals y times 3. Of course, this will perform this mathematical operation before it actually prints it out. And then I mentioned the otherwise is really else. And all you have to do with else is create that code block and put what your else condition was. And I'm going to copy this one. Helps me when I don't have to type. And I'm going to change this to value equals 40. Value is 42. Fill that in. I don't need this. And so in this case, we had y is 14. 14 times 3 would be 42. So in this case, since 3 times y is 42, and 42 does not equal 42 is false, it will skip this statement and perform this one. So if I hit run, you see value is 42. So it actually took the else condition. Let's say I'm just going to make this 43, which we know this is now going to be true. So in this case, it will actually print what the value is, which would be 3 times y, which is 42, and will not perform this one. So I'm going to go ahead and hit run, and it did exactly what we expected it to. Value equals 42. So that's it. That is a if statement. Of course, only if it's true, we'll do the block afterwards and then continues the flow of its program like nothing's happening. And if else is if the value is true, it will perform the first code block. Otherwise, if the value is, if this condition is false, it will perform everything in the second code block. That's the concept of an if-else. Now we can actually go even a little bit more fancy. There's times that you might not just say true false. There may be multiple cases of wanting to test multiple things. It could be different variables, different conditions, or again, there's a case of less than, equal to, greater than. That's a perfect example. Matter of fact, that's a good example to do here. Let me go ahead and write up my pseudocode first, and then I'll tell you what we're going to do. So we're going to say if a variable, we'll use y again, is greater than 5. Now this is greater than, not greater than or equal to. This is greater than. I'm going to go ahead and I'm going to print greater than 5. Now again, we did greater than. Well, what about if that's not true? What if that same variable is less than 5? Print I'm less than 5. I'm actually going to copy this and change a word because I'm faster that way. I'm less than 5. So I'm checking value of y. If it's greater than 5, I'm going to print this. If it's less than 5, I'm going to print this. But what if it is 5? Because if it's not this, if this is false and this is false, there's really only one other thing it can be. Print I am 5. So here's again, this is the case. If it's this, print this. Else, if it's this, print this. Else, print this. And I kind of gave you what the command we're going to use, and that would be your if, else if, else. So in this case, we know we have an if, and we know, once again, if y is greater than. We know if y is greater than 5, I'm going to go ahead and print this off. Of course, stealing code from above. It's not stealing if it's your own code. And I'm going to take what's inside this parentheses and I'm going to fill it out here. So in this case, y is greater than 5. Else if, on the same line, I'm going to check for y is less than 5. Looks just like this if, except it has the else in front of it. So if this is true, do this. Else, which means this is false. Else, do this if. If that's the case, taking my code once again, I'm less than 5. So if it's greater than 5, do this. If it's less than 5, do this. So if true, this. Else, if this is true, this. Else, which means it's neither greater than 5 or less than 5, therefore it can only be one other thing. I am 5. So let's go ahead and run this. And of course, looking back, we know I'm going to hover over my 5. I know 5 is 14. So 14 is going to be greater than 5. I'm going to hit run, and it says I am greater than 5. I am going to, just for the sake of testing every one of our conditions, and another important note, test every one of your conditions. Make sure they are exactly what you expect it to. Not quite a unit test, and we'll go into that testing piece. Just understand, is your program flowing the way you expect it to do? So in this case, we know y is 14. 14 is greater than 5. It prints this one. So I'm going to say y is negative 14. Reassigning it right there. Hit run. It should put up my second, saying I'm less than 5, and it did. And then I'm going to go ahead and set y equals 5, and it should fall out to that final else. I am 5. Easy peasy, pretty straightforward. The nice thing, I'm going to go ahead and comment this one out. What's nice about this, it reads pretty straightforward. If y is greater than 5, do this. Else, if y is less than 5, do this. Else, do this. Kind of very English-ish. It's not a real word, but we'll use it in today's video. But that's pretty straightforward. So that's your if statement, your if-else statement, your if-else-if, else statement. You can do an if, else if, else if, else. You can just continue this over and over and over again. It does get very messy. There is a way we're going to go work around that, but we're not going to talk about that quite yet. There is one more case that I want to talk about with if statements, because in what we're doing, we are going to do a test, but there's a potential that, inside your next code block, there may be something else that you want to test. There may be another check you're going to want to do. And to do a little pseudocode to explain what I'm talking about, let me go ahead and write this out. I'll say if a variable y is greater than 5. So we've tested y. So if y is greater than 5, if that condition is true, maybe at this point I want to check x. So there is sometimes times when you might want to take what's in this if statement and do a compound Boolean equation. Of course, if you remember, compound Boolean equations would look something like a plus, put it in parentheses, a plus b is greater than 5. Go ahead and group those together. And then we use our and or. We'll do an or. C plus d is less than 17. Surround those. I am grouping those Boolean equations because I want to know, if this is true or this is true. And so I put those extra parens. A lot of times it's more for readability, and I highly suggest use as many parens and as many curly braces for code blocks that makes it as readable as possible without being very messy. So in the case of this, I know it's either this or this. That's a compound Boolean equation. And if you want to know more about compound Boolean equations, again, check out my last video. I beat Boolean equations up pretty good. At least I felt so. But sometimes if one value is true, that's when you want to check a second value. So in a case of this, let's say if variable y is greater than 5, I'm going to go first off, I'm going to do my else statement. You notice otherwise typically means else to me. I'm going to go ahead and print initial case is false. So basically what I'm going to check is that I'm going to check this test case, this Boolean equation. If it's true, it means I want to do some other stuff. So in this case, I'm checking y, and maybe y, the only reason I even want to check y is to know if I'm going to go and check x. So in this case, I'm only going to do this if x is less than or equal to 20, only if y is greater than 5. If y is not greater than 5, I don't care what x is. In that case, it's going to print initial case as false, and we're going to move on. But if this is true, I might have another if statement. In this case, I'm going to print both cases are true, which means this y is greater than 5 and x is less than or equal to 20. Both of those are true. Otherwise, going to print first case is true, second case is false. So in this case, this is true. If you get this, it means y is greater than 5, x is less than or equal to 20. If y is greater than 5, but x is not less than or greater than 20, we'll print first case is true, second case is false. If y is less than 5, or less than or equal to 5, that is, we'll say the initial case is false. We don't care about x. We're going to skip it. This has a name. It's still an if statement. Matter of fact, it's an if else statement, just as we did above. But you actually will hear this be called a nested if or a nested if else. Very useful when you need one condition to be either true or false before you test something else. Because honestly, you could, while this if has this if else inside of it, you could actually have one in your else clause too. You could also have where if this is true, you might have something minor here, and then your second if else be in your else statement. That's a little messier. That doesn't occur as frequently. Typically, you want to do a positive logic where you're testing for truth. And if you found that your second case is where your if else goes, maybe you change your Boolean equation to kind of be the opposite. It'll work both ways. It's usually just cleaner that way. You're not doing what's a lot of times people call not logic, but understand it does work both ways. But these nested ifs, I will tell you, this is where it can get very, very messy. And the reason why I'll say it's very, very messy, let me go ahead and I'm gonna go ahead and write this code so that you see what we're doing. And so we know we have an if statement in our block. I'm not doing my equations yet. And we have my else. And of course, my else is going to be nice and easy. I'm going to go ahead and steal this line of code right here. And I'm going to print what's here. Very simple. And inside this block, I'm going to have another if. Go ahead and put the structure there. And I'm going to go ahead and steal this code once again, because I know both of these are going to have couts to them. And I'm going ahead and get what I wanted to print. There's my first case. There's my second case. So in the case of this if else inside, I know I'm going to check for variable x is less than or equal to 20. Cut and paste this, and then of course I don't need the word variable, I just need x, and I need to know if this is less than or equal to 20. So this fulfills this part here is this. So what do we have left? We have what's left here, And we'll say cut and paste this, that y is greater than 5. So that this if here is this code. And of course, the else for that first piece is right here. And the inner if is right here, which is right here. Now, as you see, this, I mentioned, it can get really messy. And I'm going to go ahead and we're going to test this. We know 5 is 14. So we are going to go in this first case. We're not going to do our initial case as false. And if you're noticing that I do hover over this, but I know we're going to go into this first case, and then x is 90. 90 is not less than 20, so it's actually going to go into this. So what we should print whenever this runs, assuming we have no syntax errors, which I don't think we do, we should see first case is true, second case is false. Go ahead and hit run. Let's see if we're correct. And it is correct. First case is true, second case is false. Again, it's always good. Now we can run through every test case, and I highly recommend when you're doing, especially when you start talking nested ifs or the if else, and when they start getting kind of large, and they will, test every condition. We're not going to do that here because it will work. I'm not worried about that. But one thing I will comment on, don't be surprised when you hit run. You should honestly know exactly what you're going to see when you do hit run. So the fact that I knew y is 14, that's greater than 5, I knew I'm going to hit my first case. And then I checked my x. I know x equals 90. It's not going to be this truth. It's going to go into the false. So again, checking it before I hit run. And then really what run will do is it's just going to verify what you expect it to be. Now, I did mention this is messy. So in this case, there is a lot of code here. And it's a lot of code to really print one line. It's the check two values and print one line. Nested ifs can nest pretty deep because I could honestly, inside this if I have this if else. And inside this if else could actually be an if else. Inside like this truth condition could be another if else. And inside that true could be another if else. It can go deeper, 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 deeper. Just because I have indentation here does not mean anything. I can't stress that enough. Indentation means nothing to C and C++. There is languages that it does. C and C++ is not one of those. I could have every one of these justified to the left all the way, and it will be exactly the same. For readability, for honestly your sanity, use indentation to understand, to help readability of your program. Honestly, if I say readability any more times, if anything, that should be the one thing I will stress. Make your programs readable. But, I have indentations here so that I can see, I know that everything that's indented here is between these two blocks. So be careful, indent, make your code readable. When you start nesting, if you nest more than 3 or 4 deep, you might want to figure out better ways. But, sometimes you can't. I just let you know, sometimes it has to be what it is, but be very careful because the more you're nested, the longer these will get, and you'll end up not being able to see your complete conditional piece here on one screen. I'm going to hit run one more time, make sure we're coded, that everything's working, and it's fine. Again, making sure we're in a good state before we move on. Last thing I wanted to talk about, and I did mention earlier that most conditionals in those conditional flow controls are Booleans. Everything I've shown you, these are all if statements, and it's really if true or false. But sometimes it's beyond a Boolean condition. Sometimes, like if, else. This is a case where I have basically 3 different jumps. I'm testing a value 3 different ways. There is an easier way to do this. There also may be a case of I have a value that can hold more than, in this case, it's holding 3. There may be a case where a value can hold more than 3. So let's do this. So obviously these, when we're talking about numerics, and it could be numerics, it can be characters, it could be anything. They can hold values, an infinite number of values, honestly. Well, not infinite because we have only so many bits to work with. But let's look at, let's set up y. So obviously I can say something like y equals 1. I can also say y equals 2, and on and on and on. Well, the last thing I want to ever do is, let's imagine that if else. Let's say y can be one of, let's say can be one of 4 different values, just for fun. I could say if y equals 1, do this. Else, if y equals 2, do this. Else, if y equals 3, do this. And if you imagine, this is very, very repetitive. But you can actually write this if, else if, else if, else if, else if, else if, and I'm not stuck on, saying the same thing. You can write a ton of values. Y, as we remember, can be a very, very large number. There is a case that you can actually handle every one of those cases without having to do that else if, else if, else if, else if, on and on and on, because again, it gets very, very repetitive. This is a case of, as I mentioned before with a river, you might have water go to the left or go to the right. It's one or the other. Well, there is a case of, for example, if you look at a railroad yard, and railroad yards, there can be multiple tracks that a train can go. And of course, how do you control which track a train goes down? Well, usually it's with a switch. You either, set it for track A or track B or track C or so on. And, and while there's a finite number, it's more than 2. So, that switch can actually redirect it to whatever track you want it to go to. Of course, a track is exactly what that is. It's a flow control, right? It's just like that water going down, left or right. We are going to control the flow of the way our train's going to go, and we're going to use that switch. Well, here's the fun thing, and the reason I brought up trains is because to do what I'm talking about without those if, else, if, else's uses a command in C and C++ known as a switch. So we're going to go ahead and put that down here. So we have a switch command, and a switch does exactly what it does on a train track. It will switch to whatever flow you want it to go down when you have more than a true or false answer. So I set my y equals 1, but let's go ahead and look at some pseudocode that I want to show you. So this is a case of if a variable y is equal to 1. If it's y equals 1, let's go ahead and print, let's say y equals 1. Be real creative here. Otherwise, if y is equal to 2, we'll print y as 2. Again, being very creative here. This is some very boring pseudocode, but I just want to get the point across. Otherwise, if y is equal to 3, say y is 3. Otherwise, if y is equal to 4, and of course I can do this on and on and on. I'm not going to do that. We're going to check these 4. So say our train only has 4 tracks. But y is equal to 1, we're going to print 1. If y is equal to 2, we're going to print 2. If y is equal to 3, we're going to print 3. If y equals 4, we're going to print 4. Otherwise, we're going to print not one of the values. Sounds good. And based on what we did before, we knew we could actually accomplish this with a if, else if, else if, else if, else. Perfectly valid. It would compile. But I mentioned this switch because this switch is almost a shortcut way of doing things. So what we're going to do, I'll show you how we do this. Actually, I'm going to bring this y here so we have it handy, because we're going to test this one out, and we're going to test every one of these cases out because I want to show you how it works. But to call this command, this switch command, as I mentioned, it looks a lot like the if, but this is basically what we're going to check against. And so what we do here, this is not going to be a Boolean. This is simply what we're going to test. And we'll state that for every instance of y, there should be a case that handles it. So what we start off, and this is a case where a code block is necessary. Go ahead and take this down just so you can see those lines together. So this is a case where a code block is necessary because everything that's under here are the cases for this switch, cases for y, where this switch is going to happen. So in this one, let's say, here's the keyword. We have case of 1. We're going to go ahead and print my line here, and we'll say y is 1. I'll go ahead and duplicate that. So we have cases 1, 2, 3, 4. Of course, we also have a 1, 2, 3, and 4. And so in this one, what we're expecting is that if looking at our y, evaluating our y, depending what y is, will tell us which track, which case are we going to call. So I'm going to go ahead and hit run here, and I want you to see how this is going to go bad. So let's save it, hit run, and if I set this to 1, our initial expectation is it's going to print y is 1 and call it a day. And I'll show you why it doesn't happen. So I hit 1, I run, and you notice it says y is 1, y is 2, y is 3, y is 4. Now, I did mention that this under the switch has to be a code block. And the important thing about a code block is that there is a shortcut out of the block. Since this is one code block, all these pieces of code, they're tied to each other. But what we want to do is that when we evaluate and know that it's case 1, we print this line and then we're done. We should be done with that switch statement. So how do we get out of that? And that is actually has to be done with our, we don't use goto because gotos are bad, and we can go into that in another day, but there is a way to get out of a code block, and it's known as a break statement. Break simply means this: get out of the current code block I'm in, out one level. So in this case, if I put a break here, what this will tell me is if it evaluates the y being 1, I hit case 1. Of course, this is a colon after the 1, not a semicolon. I print the C out, and then I break out of this code block to the outer level, which means I go to here, and then I finish the program. So in this case, this one should say y is 1, which is correct. If I set this to 2, it actually will say 2, 3, 4. And the reason it says 2, 3, 4 is because I don't have breaks at every single one. So in this case, I'd want to do that break at every single one. I'm putting a break here, even though if you look at this code, this break will bump us out to the outer level because there is one part of our pseudocode we didn't handle. We didn't handle this otherwise, this last else. But we're going to go ahead and let me run this, show you this should print y equals 2, and it does. And if I did 3 or 4, it would do any of those. Actually, what's kind of neat, let's say if I comment out this break and I still leave this to 2, it will actually print 2, 3, and then break out because it will continue down until it hits the first break. It did. This is a, sometimes there's cases where you want to do, where you'll have multiple cases that will do the same thing. This is real common when you're dealing in characters. And maybe you want to check a character both lowercase and uppercase. And so even though this is going to be incorrect what I'm doing here, but you could have something like case tick A, case tick capital A. There's a space there. Both of these, if you have a lowercase or an uppercase, it would basically start the code right afterwards. So in this case, there is no break because you would want to handle both of these conditions. It's also very common if, again, let's say I want to say y is 2, y is 3, but for y is 3, I only want to say y is 3. It'd be a case like this. You'd actually you put your statements in the order that would make sense and would fall through by not putting the break. So in this case, if I set y is 2, it's going to print y is 2, y is 3. If I do y is 1, it will only print this one. If I do y is 3, it would only print this one. And if y is 4, it will only print this one. So it's a fun one, and sometimes you will reorder your case statements depending on how you want those fall throughs to occur. But in this case, we're going to just break on every single one of these, but we're not handling this one. Well, for all switch statements, you will call out every instance of case, and every instance that value can be. But if you want to handle everything, if you want to be totally complete, and you don't have a case for every value, you have this else that might be your catch-all. And a lot of times this might be if you're expecting y to be 1 through 4, but someone inputs a 97. You want to gracefully handle that. So 97 would actually not fall in here, it would fall out. But you might want to actually have a statement knowing that somebody put in a value that doesn't make sense. Well, that is actually done with the keyword default. And what default is that if it's not one of these cases, this is the case. It's your default value. And in that case, what I can easily do, I will go ahead and print the statement that I said, which is not one of these values. So in this case, if it's 1, say y is 1, 2, y is 2, 3, y is 3, 4, y is 4, anything else we'll say it's not one of the values. Default has to be the last piece of a switch statement. I'll repeat that. Default is your last, we'll call it case. I'm doing air quotes around case, but it is the last piece of your switch statement. Because it is the last piece of your switch statement, default does not require a break, because after this falls out, it's out of the code block. And show you, I'm gonna go ahead and I'm gonna say 4. I hit 4. It will say y is 4. And then I'm gonna go ahead and say 5. In this case, it will hit my default. Yep, not one of the values. Hit my default. That's it. I can be really funny here. Go ahead and hit 4. Understand that it's going to fall through down to the default once again. So I'll say y is 4, not one of the values, because it does fall in. And actually, let's see. Yeah, that's there's your unannotated fall through. So that's it. That's a switch statement. Again, I use a number here. You can have characters here. You can have any value as long as it has discrete values that you can actually check against. So that's it. That is the 4 conditional flows that I wanted to show. Now, for those that were waiting to find out what was that special surprise, what can I give you that's going to help you become better programmers? Since my assumption, if you're watching this video, you're either new to the language or new to programming, I cannot stress enough that to become a good programmer, you have to write code. You have to practice, everything you're watching. You can watch this all you want, and until you put hands to keyboard, it's just not going to stick. Sometimes it's difficult to come up with how am I going to expand myself. Well, that's what I'm going to start doing from this point on with every one of these videos, these ones that I'm going to teach you language pieces. What I want to do is I want to challenge you. So what we're going to do is I am going to give you a challenge question. Now, I did show you pseudocode. It is a way to write and explain what we want to do without writing the code, leaving the syntax up to you. At the end of every one of these videos, these challenge questions I am going to give you some pseudocode. This pseudocode, basically everything that I've taught in this episode and anything before this is fair game. There may be little pieces that I would write that I mentioned in passing. They're all fair game. So what I'm going to do is give you this pseudocode, and I'm going to give you a chance to figure it out on your own. And the answer is not going to be part of this video. What I'm going to do is I am going to shortly put up a second video. It's going to be a short, which means I'm going to do this in under 3 minutes. I'm going to take this pseudocode and I'm going to write the code as I would write it. It might not be exactly the same. That's the glorious part about coding, is that we all have different ways, either that we do it because of style or just in flow in general. As long as you get the right answer, it's fine. But if you get stumped or you just want to check what you do, definitely check out my channel, which is a good reason to subscribe, because I'm not going to put this out right away. It may be another day or two, but I am going to put up a short so you will actually see how I would write this code. So let's go ahead and start with my challenge question number 1. It's going to be a doozy, I'll tell you that right now. So here's what we're going to do. I'm going to ask you, okay, let's say if, and I'm going to put some of this is going to be in parentheses so that I'm easier to understand what I'm doing. But if I have a variable a, and I'll give you what the a, all the variables, the value that I'm going to start with at the end of this, so that when you write this, when you run it, you should get the exact same thing that I'm do whenever I put it out. But if I have a variable a and it's equal to 17, and hint, whenever I put these capital things that mean something, and b is not equal to 9, let's say that, or hint hint, the sum of a and b is equal to 39. If A minus B, hint, indentation matters, is equal to 8, let's print Hickory Dickory Dock. Let's do some nursery rhymes. Why not? Sounds like fun. Otherwise, type straight to be awesome. I'm going to print, let's see, pick another one. Jack and Jill went up the hill. Does this look familiar yet? Otherwise, if a variable A minus the product of B and 3 is equal to -2. For math was a couple episodes ago if you wanted to remember how to do some of this. If a variable C is equal to tick A, and hopefully you remember what, if I surround something with ticks, what that means, we're going to print short and stout. Otherwise, if C is equal to tick G, I'm going to print I'm a little teapot. Why not? It's not quite little and definitely not a teapot, but otherwise, if C is equal to, let's say X, print Humpty Dumpty. Otherwise, this is a long one. That's why I'm not going to put the answer in this one, because I want you to think about this one. I want you to practice this one. If C is equal to tick Y, print sat on a wall. Might up with Humpty Dumpty there. Otherwise, I'm just going to print not a rhyme. See, this is kind of a catch-all, so it probably is a hint of what this one is. And of course, we have if, otherwise if, otherwise. Let's just print, I'm out of nursery rhymes. And that's it. That's your challenge question. Now, you should be able to see what the structure is. You probably will see based on everything I've done, everything we did above. And if you don't, definitely go back, look again on what we did, because it kind of matches my pseudocode above. But if you want to do this without going back and checking and whatnot, here's the values that I'm going to use to test this one. So I'm going to let A is going to be 23. B is going to be, say, yeah, I do have A, B, and C. B is going to be 15. And C is going to be tick G. So obviously, just a hint, there is two different types here. So if you remember types, that's going to be a few episodes back. But that's it. This is your challenge program. Again, I will be shooting a very quick taking this and writing it up, and using these values will show you what I get. Subscribe to the channel so you know when I put, definitely hit notify, because whenever I put that short up, you want to know it's there. Making sure that if you think it's right, well, good way to check yourself. But that's it. That's today's lesson. So let's go ahead, go back to our slide and talk about what we covered. So for today's episode, we did talk about code blocks. And now as we use them in this lesson, you're starting to see why they're very important. Easy concept, very important. We talked about pseudocode. And of course I spelled it wrong, but okay, it's EU, not UE. But we talked about pseudocode. Basically a way to get your thoughts down, or to do our, like I said, our challenge problem, where I gave you what I wanted, what I want you to do. I gave you basically the algorithm and let you put it down in code. So you have plenty of time, take your time, practice that. And then we talked about the 4 different types of conditional controls. We talked about if else, if else, and switch. And of course, we talked about nested if, or nested if else, depending on what it is. It's not really a different type of conditional flow, but it's another important one that I definitely wanted to point out. For our next session, we are going to go even further down into programming. From this point on, things will feel much like programming. These are not just defining variables. There is going to be things that we're going to control how our program works. So the next session, we're going to talk about loops. Another very important part. All languages have them. We all use them, and will get you in trouble. So you definitely want to hit the subscribe and be part of the channel, and notify whenever I put it up. It'll probably be in a week or so. I'm trying to do these at least once a week. Now that I'm adding challenge programs, hopefully I can still get a long form and a short form in the same week. It's fingers crossed. It's still learning this whole process. But I hope you enjoyed this one. Again, it feels more like programming when you start getting into how your program's going to flow. We're going to build from here. So I'm happy you're coming along. Definitely want to become part of the channel, and we're going to have some real fun. But definitely try the challenge program. Even if you've programmed before, make sure that concept sticks in your brain. Without hands on keyboard, it's hard to retain. Hope you enjoyed it, and enjoy that challenge. Bye now.